Hello everyone, and welcome to this lesson on finding lines of best fit. Our objective for this lesson is to estimate a line of best fit from a set of data and use that line to make predictions about our data. Before we begin, we're going to go over two important ideas: slope and y-intercept. We're familiar with our linear equation in the form of y equals mx plus b. In this equation, m stands for our slope. That is how steep our line is. The bigger the value of m, the steeper your line is going to be. And our y-intercept, where the line crosses the y-axis, is represented by b. You can see I'm putting some green where that would be on my graph here. Those two values are going to be important in being able to calculate the equation of our line of best fit. Let's take a look at some data. Here we have the number of hours students studied for a test and the scores they earned. Take a look at the data to see if you can find a trend. Now let's plot it to explore further and answer the question we have on our slide here. Each point we have plotted on our graph here represents a student's data. Do you see the trend? Now we're going to draw a line that best fits this trend. It doesn't need to go through every point because the data isn't linear. It should just match up with the overall direction. A good rule of thumb is to try to have an equal number of data points on each side. I'll go ahead and draw my line here. As you can see, it's going through a couple of these points, but not all of them. And you can see they're dispersed pretty evenly around my line. Here's where we get to do a little bit of math. Now that we've put our line on the graph, we're going to calculate the slope. We're going to pick 2 points from our line and use our rise over run to figure out what our slope is, or how steep our line is. I like to pick points that are where 2 of my graph lines intersect, because then I don't have to estimate their value and my math will be more accurate. I'm going to pick this point and this point. My first point is going to be 270. My second point is 480. Here we can use our slope triangle, our rise over run. We're going up from 70 to 80, so our rise is going to be 10. Our run, our horizontal direction, is going from 2 to 4, so that's going to be 2. And our slope, or our m value, is going to be 5, which means that every extra hour of studying increases your score by 5 points. Now that I have my slope, I have the information I need to calculate my y-intercept and find my full equation. Going back to that linear equation, y equals mx plus b, I can start plugging in my values. So I'm going to choose a point from my line. Let's go with this point right here, which is 270. I take my y value, which is 70. My slope, which is 5, multiply that by my x value, which is 2, and at the end we have that plus b. So we're solving for b here. Let's do our math out. 70 equals 5 times 2 is 10 plus b. Subtract 10 from both sides, and we're left with 60 equals b. That means the equation of our line is y equals 5x plus 60. And we can use that to help interpret our data. Since we have the equation for our line of best fit, which is y equals 5x plus 60, we can use that to predict the test result of any number of hours of studying. So if our friend tells us they studied for 4 hours, we can go ahead and plug that into our equation. Y equals 5 times however many hours, so 4, plus 60. If we do that math, we have 5 times 4 is 20, plus 60. We predict that our friend is likely to get an 80 on their test. So let's review. Our objective at the beginning of this lesson was to calculate and interpret lines of best fit. Did we do that? For calculating, we plotted data points on our graph, estimated our line of best fit, found the slope, intercept, and wrote the equation. For interpreting, we used our line to predict the outcome of a piece of data. So there we go. That's how you find and use a line of best fit.